Hello everyone, and today I am going to tell you about partial differentiation. Basically, I am going to tell you about the homogeneous function in two variables, and then I will tell you Euler's theorem for homogeneous function, and after that I will tell you how to apply Euler's theorem. And it is very important for you, basically in mathematics honors and physics honors. Okay, let us start. What is the meaning of homogeneous function? F of xy is a function of two variables x and y, and it is said to be homogeneous function in x and y, not xyz, in x and y, if, and that is having degree n, in x and y of degree n, if f of x px dy is equal to t to the power n into f of xy. Again see here, f of px ty is equal to t to the power n into f of xy. If by putting tx in place of x and ty in place of y, you will get t to the power n into f of xy. Then the function f of xy is said to be a homogeneous function in x and y of degree n. Let us see an example. After that you can understand. So let f of xy is equal to x square plus 2xy. Okay, let us test whether this is a homogeneous function or not. Now, according to our definition, f of tx ty, that means in place of x I have written tx, in place of y I have written ty. Okay, so this becomes tx whole square plus 2 into tx into ty. Now it becomes tx whole square means t square x square, t square x square plus 2 t into t, it is t square xy. So let us take common. T square is the common, then x square plus 2xy, x square plus 2xy, and this becomes t square, and this one see here, x square plus 2 x square plus 2xy, it is your f of xy. So t square into f of xy. Now this is in the form of t to the power n f of xy. If your answer is in the form of t to the power n into f of xy, then it is a homogeneous function. And what is the degree? The degree is 2. That means f is a homogeneous function in x and y. You have to mention the variables in x and y of degree 2. Clear? So this is all about homogeneous function. And you can write the degree also. So directly we can see here, homogeneous function means the degree of each term in the given function should be same. Here, see here, f of xy is equal to x square plus 2xy. The function which I have written in the previous example. This is of degree 2. This is also of degree 2 because 1 plus 1 it is 2. That means each term is of degree 2. So the given function is a homogeneous function in x and y of degree 2. Okay. So let us see here. What is Euler's theorem? If u is a homogeneous function, if u is a homogeneous function in x and y of degree n, then x into del by del x of u plus y into del by del y of u is equal to n into u. Again see here, x into del by del x of u plus y into del y of u is equal to n into u. X into del x of u, y into del y of u is equal to its degree into the given function. Okay, this is Euler's theorem. Now, let us apply this theorem to some functions so that without partial differentiation, we can find out the result. See here, very interesting theorem with a problem I am going to tell you. See here. If u is equal to sin inverse x square plus y square divided by x minus y, then x into del x of u plus y into del y of u is equal to tan u. See here, given u is equal to sin inverse x square plus y square divided by x minus y. Here, it implies, let us take sin inverse to this side. So it becomes sin u. Sin u is equal to x square plus y square divided by x minus y. So let it be f say. Here. Now the numerator is of degree 2 and the denominator is of degree 1. So 2 minus 1, it is of degree 1. The numerator is a homogeneous of degree 2 and the denominator is a homogeneous in degree 1. So 2 minus 1. That means I am applying the formula a to the m by a to the n is equal to a to the m minus n. Clear? So the degree of numerator is 2 and the degree of denominator is 1. So 2 minus 1 is equal to 1. That means here f is a homogeneous function in x and y of degree 1. Here, so we can apply Euler's theorem because Euler's theorem is applicable to homogeneous functions only. Okay, so by Euler's theorem, x into del x of f. Here f is a homogeneous function. See here f is a homogeneous function. X into del x of f plus y into del y of f is equal to 1 into f because the degree is 1, so n into f. Okay, so it implies x into del x of, here see here f is equal to this one is equal to sin u. In place of f I can write sin u plus y del y of sin u is equal to 1 into sin u, it is sin u. Clear? So the derivative of sin u, it is cos u into del u by del x. X into derivative of sin u, it is cos u into del u by del x. This is y. Again the derivative of u with respect to y. Cos u into del u by del y is equal to sin u. So I am dividing cos u on both the sides. So it becomes x into cos u cancel out, remain del u by del x plus y into del u by del y is equal to sin u by cos u, because I am dividing cos u on both the sides. So sin u by cos u is equal to tan u, which is your requirement. Okay. So if there will be any doubt, then please ask me in the comment box. Okay. So let us move to the second example. See here it is given u is equal to cos inverse x cube plus y cube divided by x minus y. Here, so it implies now cos inverse will go to the left hand side. It becomes cos cube is equal to x cube plus y cube divided by x minus y. Is that clear to you? So let it be f say. Now see here, what is the degree? Whether this is a homogeneous function or not, let us say. Here the numerator is a homogeneous of degree 3 and denominator is a homogeneous of degree 1. So if it is in the form of p by q, then the p must be homogeneous and q must be homogeneous, and both may be of same degree or different degree. But p must be homogeneous, q must be homogeneous. Then only p by q will be homogeneous. Okay. Now what will be the degree? Degree of p minus degree of q. So here the degree of p is 3 and degree of q is 1. 3 minus 1 it is 2. That means f is a homogeneous function in x and y of degree 2. Therefore f is a homogeneous function in x and y of degree 2. 3 minus 1 it is 2. So we can apply Euler's theorem because Euler's theorem is applicable to homogeneous functions. So by Euler's theorem, x into del f by del x plus y into del f by del y is equal to degree is 2. So 2 into f. Here. So we can write implies x into del by del x of f. And here f is equal to cos u. So in place of f, I can write cos u plus y into del by del y of cos u is equal to your 2 into f. That means 2 into cos u. Okay. Now see here. X into derivative of cos u. Your derivative of cos u is minus sin u into del u by del x. Again here, derivative of cos u, it is minus sin u into del u by del y. Here it is given with respect to x, here it is given with respect to y. So minus, that means this plus will become minus y into sin u into del u by del y is equal to 2 into cos u. So I am dividing minus sin u on both the sides. I am dividing minus sin u on both the sides. So this minus will cancel out, sin u will cancel out. X into del u by del x. And this becomes plus. Y sin u cancel out, remain del u by del y. And I am dividing minus sin u. So minus 2 cos u by sin u. Minus 2 cos u by sin u, it is cot u. So minus cot u. Okay. So let us see another example. Here it is given u is equal to cos inverse x plus y divided by root x minus root y. Here. So It implies cos u will become x plus y by root x plus root y minus root y. Let it be f say. Now here f is in the form of p by q. Here p is a homogeneous function p. That means the numerator is a homogeneous function of degree 1 and q is also a homogeneous function of degree half. That means p by q. That means f is a homogeneous function. Now what will be the degree? The degree of numerator is 1 and the degree of denominator is half. So 1 minus half, it is half. That means f is a homogeneous function in x and y of degree half. Therefore, f is a f is a homogeneous function in x and y of degree 1 by 2. Okay. So now since f is a homogeneous function, we can apply Euler's theorem. So therefore, by Euler's theorem, x into del f by del x plus y into del f by del y is equal to degree into f, and the degree is half. So half into f. So what is the value of f? Here f is equal to cos u. So in place of f, I am writing cos u. Okay. So x into del by del x of cos u plus y into del by del y of cos u. So is equal to half into cos u. Simply I am writing cos u in place of f. So it implies x into derivative of cos u, it is minus sin u into del u by del x. And here the derivative of cos u, it is minus sin u minus y sin u into del u by del y is equal to half into cos u. I am dividing minus sin u on both the sides. So minus cancel out, sin u cancel, remain x into del u by del x plus y into del u by del y is equal to, I am dividing minus sin u. So minus half cos u divided by sin u, it becomes minus 1 by 2 sin u by cos u, it is cot u. So minus half cot u. It is the required answer. Okay. So let us see another example. This question is your homework. So similar question I have already done. So this is your homework. Okay. So I am going to the next example. See here. This one also equal to same. Only the function is different. X square plus y square divided by x plus y and sin inverse already I have done it. So these two is your homework. Let us see. Second one. This is a different question. So I am going to tell you given u is equal to sec inverse x cube minus y cube divided by x plus y. So it implies sec u will become x cube minus y cube divided by x plus y. Let it be f set. Now here f is in the form of p by q and p is of degree 3 and q is a homogeneous function of degree 1. So that means p by q is a homogeneous function. That means f is a homogeneous function. And if it is homogeneous, then what is the degree? So the degree of numerator is 3 and the degree of denominator is 1. So 3 minus 1 is equal to 2. That means f is a homogeneous function in x and y of degree 2. Therefore, f is a function in x and y of degree 2. And since f is a homogeneous function, so we can apply the Euler's theorem. Therefore, by Euler's theorem, x into del f by del x plus y into del f by del y is equal to the degree of f is 2, so 2 into f. Here. So in place of f, the value of f is sec u, so in place of f, we have to write sec u. So x into del by del x of sec u plus y into del by del y of sec u is equal to 2 into sec u. So let us see what is the derivative of sec u. Derivative of sec u is sec u into tan u into del u by del x, because it is given with respect to x. X into sec u into tan u into del u by del x. Similarly, here with respect to y, sec u into tan u into del u by del y. It is equal to 2 into sec u. Okay, so let us divide sec u into tan u on both the sides. So remain x into del by del x plus y into del by del y, because I am dividing sec u into tan u on both the sides. So here sec u tan u cancel out, here sec u tan u cancel out, and we are dividing 2 sec u divided by sec u into tan u. So sec u cancel out, remain 2, and 1 by tan u will become cot u. 2 cot u. Here it is. The required value on the RHS is 2 cot u. Okay, let's see here. Another example. This example is a logarithm. Okay. And finally, I will tell you how to write directly without solving. That means for 1 mark question, and as well as for any entrance. That means for NET exam, for GATE exam, and for the other exams. Okay. So I'll tell you how to write the answer directly without solving anything. Okay. So see here. Here it is given u is equal to log x to the 4 plus y to the 4 divided by x plus y. That means here log means base e. If there is no base, then it is base e. So e to the power u is equal to x to the 4 plus y to the 4 divided by x plus y. So let it be f set. That means here f is in the form of p by q, and here p is a homogeneous function of degree 4 and q is a homogeneous function of degree 1. So that means f is a homogeneous function of degree 4 minus 1, it is 3. Okay. So therefore f is a homogeneous function in x and y of degree 3. Okay. So now we can apply Euler's theorem because f is a homogeneous function. So by Euler's theorem, x into del f by del x plus y into del f by del y is equal to 3 into f. So in place of f, we can write its value. Okay. So x into del by del x of its value plus y into del by del y of its value is equal to 3 into e to the u. Okay, so x into, what is the derivative of e to the u? This e to the u into del u by del x. E to the u into del u by del x plus y. What is the derivative of e to the u with respect to y? E to the u into del u by del y is equal to 3 into e to the u. So now dividing e to the u on both the sides, we get x into del u by del x plus y into del u by del y is equal to 3. So this is your required value. Okay. So let us say another example. So this type of problem I am going to tell you in a different way. Okay. So here, see here, z is equal to xy into f of y by x. That means z is itself a function of x and y. So we can write z of xy because z is a function of x and y. X into y into f of y by x. In a very interesting way, I am going to tell you. Okay. So I am going to test whether z is a homogeneous function or not. Okay. So z of tx dy is equal to, in place of x I am writing tx, in place of y I am going to write ty to test the homogeneity. Tx into ty into f of ty by tx. So here t cancel out. This term become f of y by x, and this t into t, it is t square xy f of y by x. And this total part, this one, it is z of xy. That means t square into z of xy. That means z is a homogeneous function in x and y of degree 2. Therefore, z is a homogeneous function in x and y of degree 2. So, by Euler's theorem, apply Euler's theorem. It is x into del by del x of z. We are applying Euler's theorem to the function z, not u or not f, plus y del by del y of z is equal to degree into z. Here degree is 2. This one, 2 into z. We have done it. X into del z by del x plus y into del z by del y is equal to 2 into z. In other way also you can find out. You can find out del z by del x, partial derivative of z with respect to x, then find del z by del y, then put the LHS, put in the LHS, you will get the value. But this is the easiest way. Okay. Now another question, see here. This problem also you can do in general method. That means you can find out del u by del x, then find del u by del y, then put it here, then finally you will get 0. But it will take perhaps 1 or 2 pages, perhaps near about 2 pages it will take. But I am doing in a different way. So let us see. Given here u is a function, u is not a variable, u is a function of x and y because on the RHS the variables are x and y. So u of x and y, u of x and y is equal to sin inverse x by y plus tan inverse y by x. So now I am testing, going to test the homogeneity. So u of tx dy is equal to sin inverse tx by ty plus tan inverse ty by tx. So now here tt cancel out, here tt also cancel out. Now becomes same sin inverse x by y plus tan inverse y by x. That means it is u of xy. and there is no t, that means the power of t is 0. There is no t means the power of t should be 0. That means u is a homogeneous function in x and y of degree 0. Okay. Therefore, u is a homogeneous function in x and y of degree 0. So, since it is a homogeneous function, we can apply the Euler's theorem. So, by Euler's theorem, x into del u by del x plus y into del u by del y is equal to degree. Here the degree is 0. 0 into u, which is equal to 0. We have did it. Clear? So, now question is that I have already told you how to find out the answer directly without solving. Okay. See here. From this question I am going to tell you from the logarithm how to find out the answer of this question without solving. If the question is in this form, log of something, log of anything, that means that this should be in the form of p by q or simply a polynomial like this. Find the degree of this one. Simply find the degree of this one. In the case of logarithm, if you use your log of something, then you have to find out the degree of something. That means here degree of numerator is 4, degree of denominator is 1, 4 minus 1 it is 3. So the answer will be only 3. X into del u by del x plus y into del u by del y is equal to 3. Only on the right hand side you should write the degree. Okay. Now, if it is in the form of inverse, any inverse, I am going to tell you one question. I am going to tell you so that you can do all other questions. See here, what is the trick? First, write the if it is in the form of any inverse, sec inverse, sin inverse, tan inverse, cot inverse, cosec inverse, any inverse function. Okay. For logarithm, I have told you you should write the degree only. X into del u by del x plus y into del u by del y is equal to the degree. Okay. That means log of something, it will be in the form of u is equal to log of something, and that something part is very vital part, and you have to find out the degree of that something and write the degree on the right hand side only. So here tan inverse something, sin inverse something, cos inverse something will be given, and find first of all find the degree of this one, and the degree of this one is 1 because it is 2, it is 1, 2 minus 1 it is 1, 1, write it 1 on the RHS. Now take the sin inverse to left hand side, it becomes sin u. Okay, so write sin u divided by its derivative. Its derivative is cos u. So sin u by cos u, it is tan u. So the answer is tan u. Another question I am going to tell you. After that you can understand it easily. See here, this question. Here, what is the degree of this one? The degree of numerator is 1 and the degree of denominator is half. 1 minus half, it is half. So write half. And take sin inverse to left hand side. It becomes sin u. So write sin u divided by its derivative, that means cos u. It's sin u by cos u, it is tan u, so half tan u. The answer is half tan u. Okay, so see another example. This is in the form of cos. Okay, let us see here. Here the degree of numerator it is 1 and the denominator is half. 1 minus half, it is half. So I am writing half. And cos u, it will be cos u divided by its derivative, and derivative of cos u is minus sin u. So half is there, here minus is there, and cos u by sin u, it is cot u. So minus half cot u. So this is the trick. Okay. So I hope that you can do the questions based on homogeneous functions by the help of Euler's theorem. If there will be any doubt or if there will be any type of problem depends upon the Euler's theorem, then you can ask me. Okay. So in my next video, I will tell you some more examples on homogeneous function and better example and based on Euler's theorem. And without the help of Euler's theorem, if we do those problems, then it will take maximum 3 to 4 pages and minimum 2 pages. Okay. So if you apply the Euler's theorem, then those problems will be very easy for you. Okay. So wait for my video. Till then, bye bye.